Hey, my Patrick, and today we're going to talk about the lost art of steam heat balancing act. So, it's kind of like they do call it a lost art. Art sounds a little pretentious sometimes because, in essence, what it is it's steam going through some pipes to radiators with the different variables, such as air vents at the side of the variables, main vents, and whatnot. But in essence, when you go farther into the operation of how the steam heat up works and heats up your house, then you realize that there may be some truth to that claim. That is, there is a little bit of art going on in here. In other words, the basic principles are well understood, and we're going to talk about it in a second, but the art of it, it's more nuanced. So here's our typical, more rather simplified scenario, and as you know, so you have a boiler right here, and it, as every boiler, it has some water inside, yeah. And then of course that water goes into the equalizer. This is your and then it goes into, and then you have razor, and then you have two main sides, one to the left, one to the right. And in a theoretical view of the world, what ends up happening is we have two main pipes. At the end of the main pipes, you have some kind of large main vents. And then you have a smaller vents attached to the radiators on opposite side of the entrance for the most of the part, on the one pipe steam heat, and likewise here. And then the theory is that as the boiler starts producing steam, yeah, that steam starts flowing into the pipes, and then goes here and goes here. And then, after more or less the same distance, so in other words, then it's going to start filling up this radiator, probably at the same time. And then, of course, because this is the farthest radiator from the boiler, then you want to make sure that it vents a bit earlier, so you get so the two circles implying the size of the vent. So this is double the size of the venting of this radiator. So in theory, it should be that if those two radiators are equidistant from our riser, then that means or riser, then that means the steam gets to those two radiators at the same time. They fill up with steam at the exact same time, and then immediately the steam keeps on going and then fills up with this radiator at twice the speed of this radiator because of the double venting. Now that is the theory, and in general it does work. There is a one side note though, one asterisk. It does work after the initial let's say firing of the boiler. So in other words, the pipes are warm, and that steam travels incredibly fast through the pipes, and it's going to travel the same speed, and then travel, and then starts filling up with this radiator, and this radiator starts. This one's going to start filling up slowly. This is going to start filling up faster, and then you can speed it up even by, let's say, adding the double vent or double the size of the vent. So that means by definition the steam is going to go, and then go here, and then start filling up this radiator and this radiator, and all those radiators start filling up at the exact same time. Yeah, theory and practice of a warm steam heat system. The problem that this theory forgets about is that the build-up time, namely, I guess maybe we should start there with the new page. So that's something that we often forget about, is that most of the time the steam boiler is not working. Most of the time it's kind of waiting for the call for heat. And let's say even when it works on a very cold day, let's say it works 15 minutes, then cools off. It works for, let's say 10 minutes, then cools off for 20 minutes, then then works for 10 minutes, cools off for 20 minutes, and so on and so forth. So the boiler cools off. And when the boiler cools off, let's just add some our proverbial water to the boiler with our equalizer also filled with water. again, there's no Hartford rule in any of the examples because those are simplified examples. When the boiler cools off, when there's some heat is being applied to the boiler to warm it up, there's a very small amount of steam being created. So, I don't know, let's call it a head of steam or whatever. And that steam head has a vastly different properties than when there's lots of steam in the system. And let's talk about it for a moment. So when the pipes are more or less coldish, because let's say, all right, it's not exactly, it didn't return 2 or 3 hours ago and it started the system, but rather like let it go for a certain amount of time, and then let's say half an hour later the boiler is being called for heat again. The pipes are warmish. They're not exactly cold, but they're not exactly steaming hot. So when that steam starts going into those coldish pipes, it keeps on warming up those pipes, warming up. And this is an interesting thing. So you see, you have one main pipe going in this direction, and then another main pipe going in this direction. This little distance difference, like let's say 1 foot, 2 feet or whatever, it doesn't have to be related to height. It can be related to basically on the horizontal pipe. That means that this small amount of steam will have to make a choice. And almost all the time, it's going to make this choice. Yeah. And again, it's because there is a very small limited amount of steam. So when there's a limited amount of steam, it doesn't go anywhere we would expect on a typical scenario. It goes into the least part of the resistance, the closest pipe that it has access to. So of course, there is some kind of main vent here, some kind of main vent here, and some kind of smaller radiator vent here, smaller radiator vent here, and like in our previous example, two double the venting. That all those venting, and quite frankly, let's add main vent, so it's double the venting. None of that matters. And that's something, that's where the art of steam heat balance comes in. You just started the steam boiler, it's gonna work for the next, let's say, 2-3 minutes just to warm itself up, to start producing steam, and then it doesn't immediately produce tons of steam. If you have tons of steam, it's gonna the steam is gonna behave according to the theory. But when there's a small amount of steam, it's gonna behave a bit differently. It's gonna prefer the path of least resistance, and then it goes to this closest pipe, and then starts slowly warming it up, and the speed difference is actually hugely different. So in other words, on a warm system, this steam in a warm system travels around let's call it 10 feet per second, and in a slow system you get 1/10 of that, so you have 1 feet per second. So in other words, slowly the steam keeps on traveling, and at the same time keeps on traveling, condensing back into the system. The boiler of course keeps on producing more steam, and at some point this kind of there's enough of a steam happening. I'm gonna add some steam to our boiler. Is that this is not enough? This slow what's called travel down this one pipe is not enough, and then finally the pipes the steam starts traveling in this direction. But often by this time, this steam has reached, let's say, this radiator, and let's say slowly enter this radiator, slowly start filling up this radiator, and then before you know it, let's say if this is the room with your thermostat, again, it doesn't have to be exactly close to the radiator, but just because it's within the same that room, then what you can find is that often the thermostat will calling for heat by the time most of those radiators are still kind of coldish. Let's say I'm going to fill it, this one with the radiator, and this one I'm going to totally keep it cold. So you see now. So in other words, the thermostat calls off the call for heat. The boiler stops producing steam. By definition, the steam collapses, slowly starts returning to the boiler. The pipes start cooling off, and then let's say 15 minutes later, the call for heat happens again, and similar thing happens. Now by the time maybe the pipes are a bit more warmer, so because of that, the steam kind of goes faster in this direction. So because of that, in return, there is a steam also traveling a bit faster in this direction, and maybe at some point this radiator will get some heat. All right, so let's continue. Let's talk about what we can do about all of this. So or rather how to work with this kind of like principle of the head of the steam, where there's very low steam in the boiler, moving in its particular way. The easiest thing for you is to, in essence, go to your basement and figure out what is the piping in your basement. So in other words, with this piece of knowledge, you will know that the main pipe going from the riser that's closest to the boiler, that's going to be probably one that's going to be favored by the very few bits and pieces of the steam that materials in the boiler when it starts just firing up. Another thing you might discover is that the people kind of who are laying the pipe, they would kind of try to work around it, and let's say they would put this 2.5-inch pipe or whatever, something, a largest pipe right here and a smallest pipe right here, in the hopes that smaller amount of steam, that somehow the steam will make the choice, instead of going this pipe, or rather split, instead of going just this pipe, split the difference. Again, that's where the art of it comes in. In other words, unless you have tons of experience, you will discover is that it's not as simple as this schematic, kind of the theory that we're being taught. All right, so you discover that your main pipe is going somewhere, let's say here, and then you ask yourself, okay, how do I slow down this steam as much as possible? So you don't want to stop it, but you want to slow it down so that the steam, some amount of steam, has some time to go into this this pipe as well. On my particular with my particular house, the solution was to decrease this to much smaller opening, and to decrease the opening of the air vent on my radiator to the tiniest. We're talking like a pinhole. And that allowed me to do a few things. So in other words, because the steam, because of those two things, was moving so slowly through this pipe, by the time it actually reached the radiator, there was quite enough of a steam in the system that the steam kind of, like, instead of just going to one direction, they decided to go. I mean, decided. The steam doesn't decide anything, but it just reacts to laws of physics. And then there was enough steam to actually start filling up in this space as well, and then with that I could get more or less the same amount of heat to all the radiators at the same time. Again, it was an interesting experience, I gotta say. In other words, the theory, after you kind of, and again, remember, often what you will discover is that before you get to even theoretical state of affairs, you're dealing with all old systems. There might be issues with the boiler, there might be issues with the main vents, there might be issues with vents on the radiator, there might be issues with pitch, there might be issue with a condensate return, and so on. And before you know it, there's lots of all the little issues that may stop you from even go working with the theory. It just happened that on my system, after all those issues were resolved, the theory was still not matching reality, and that's why I had to go to the so-called stage 2, where I started discovering that managing the art of venting the steam system is not as simple as the theory indicates. Anyway, I hope it was somehow helpful to somebody to convince somebody and to go to the basement and be more excited about the steam and figuring out how to actually make it work, because there's an art to it. It's not simply metal and iron and steam and heat and kind of boring stuff, but rather there's more to it. That's it.